Hello everybody and welcome to today's session Distributed Deep Learning Part 2. This session is an extension of the previous session Distributed Deep Learning Part 1 which I've already published in the YouTube. In the last session what I explained is how to install a distributed Kubernetes cluster which is basically GPU enabled, a GPU enabled Kubernetes cluster on either a cloud or an on-premises system. Today we'll explain how we will install a distributed Kubeflow cluster on top of our existing Kubernetes cluster and use this Kubeflow cluster, obviously this GPU enabled, and we'll use this Kubeflow cluster for building an entire AI framework which our AI developers, our stakeholders, or our business leaders or our data scientists will be able to use. And this Kubeflow, like as it is a distributed AI paradigm, and it has got the capability of hosting GPU, which are essentially multi-machine. So using Kubeflow, you will be capable of doing distributed training on several GPUs. And like earlier, what used to happen whenever you used to do a distributed training on GPU, the GPUs essentially used to had to reside on the same machine. But now with the advent of Kubeflow, you'll be able to schedule a single job on different machines hosting different GPUs, and even the GPUs can be of different model. So you don't need to have any kind of SLI connection or any kind of high speed connection between the GPUs. So this can actually change the entire paradigm how the AI system distribution can work, and obviously it depends on the algorithm because not all algorithms can be distributed, which I will explain probably in some other sessions of RNN or convoluted neural networks. But today, now we will go to our coding section where I'll be explaining you how to set up this Kubeflow cluster within a very small span of time inside your existing Kubernetes cluster, and we'll be also testing that whether the GPU is enabled in this Kubeflow cluster or not, and we'll run a demo PyTorch operator job which will train a machine learning or rather a deep learning model on multiple GPUs. So let's go and install the Kubeflow. First of all, what you have to do is you have to go uh, to a terminal. So it may be a Mac OS or it may be a Unix or it may be a Windows. But for this I have used a Mac OS. So we have to go to our terminal and we have to first edit the bash rc file. So before I edit, I'll show you my home. So this is the current path. So what I'll do, I'll go 2 folders up. So this will be my Kubeflow home folder, and I'll quickly remove this folder. So this is my Kubeflow home folder. So this is my base folder. So under which my Kubeflow will be installed. And what I'll do, I'll edit the bash rc file with the necessary environment setting. So as you can see, uh, the path under the path I've set the folder under which my Kubeflow will reside, and the same goes for the base directory. And this is my Kubeflow instance name. So as my Kubeflow instance name is Kubeflow -poc, so I have to create a folder under this path. I have to create a folder named Kubeflow -poc, and under this Kubeflow -poc, the customized modules will have the Kubeflow manifests. So this is how my bash rc looks like. So whenever you have to install, before you have to install Kubeflow, you have to set your base path over here and also over here, and you have to then make a directory under your base path with whatever names you like, and then you have to set the environment variables with all these names. So after you do this, you have to execute, so the changes takes place. You have to execute this command source batch rc, so the changes will now take place. So after that, what you need to do, so You have to go to this Kubeflow website. You have to go here. You have to go to the Istio v10 docs, and this is the release page of Kubeflow. So this is the release page of Kubeflow. So you have to install this kfctl. This is basically the main control command for Kubeflow. So whatever the things you'll be running in Kubeflow, it will be all in this kfctl. So you have to use this kfctl to to start the Kubeflow. You have to run this kfctl to end the Kubeflow. So this is one of the most important commands, and this is the release page of Kubeflow. So if you are using a Unix, you have to download this Unix start.gz, and if you are going for a Mac, you have to download the Darwin. So as I am using a Mac, so I have downloaded the Darwin, and once you download the Darwin, you have to use the tar. You have to enter this, and once you enter this, you will find this kfctl. So these are binary. So once you are done with all these things, what you need to do, you have to now make a folder. So I told you that you have to make a directory under your base directory under which the Kubeflow installation will take place, and the name of our installation was Kubeflow-poc. So I'll make a directory Kubeflow-poc, and I'll give the appropriate privileges so it doesn't create any hiccups later on. So now my basically this folder is ready. I guess yes, it's ready. So what I'll do, will go to this folder, and then we have to start the Kubeflow. So for starting this Kubeflow, this is a command for starting this Kubeflow, and as I initially showed you that there's one more thing probably I should show you. So I'll go to the bash rc once more. So you are seeing that there is something known as config URI over here. So this is basically the link from which Kubeflow manifests are being downloaded. So you have to set this config URI as well, and as we are like Kubeflow can be installed in two categories. One, you can install it so that like every time you have to install it and you cannot modify anything in the Kubeflow. And the other thing is that you can build the Kubeflow in your machine, and you can modify the components, you can modify the manifest, and you can start and stop the Kubeflow without needing to download all the components of Kubeflow. So there are two ways. So the second way is much more production friendly. So I'll be discussing the second way. So for running the second way, these are the two configuration parameters you have to set in the bash rc above the earlier configuration parameters which you already set. So now I've showed you what my bash rc looks like. So the config URI we have already set in the bash rc. We have to use the same config URI and we have to fire this command. See, this command will basically build the Kubeflow binary within your machine, but the Kubeflow is still not up. And let's validate. So you see, so the first thing that I want to tell you is that whenever your Kubeflow is up and alive, you will find the resources under the namespace Kubeflow. So whenever the Kubeflow installation takes place, first of all, what it makes is a namespace which is known as Kubeflow. So there are two namespaces that get built when you actually install the Kubeflow. One is the Kubeflow namespace, and other namespace is basically the Istio system namespace. So the Kubeflow code resides inside the Kubeflow system namespace. So you have seen that though I have built the command but the Kubeflow engines has still not started. That means the binary data that were required to start the Kubeflow are already there in my machine. The artifacts are there, but it hasn't started the Kubeflow. So for starting the Kubeflow, what do we need to do? For starting the new Kubeflow, you have to like export this configuration file. But I have already shown you that in our bash RC we have already set this particular environment variable, so we don't need to carry out this step. All we need to do, we need to apply. So now I will apply the command, and now it is actually making the necessary steps to start the Kubeflow. So this is how like the installation of a Kubeflow looks like. It will take some time because it will install a lot of components, it will install a lot of images, so it will take a fair amount of 5 to 7 minutes. And in the meanwhile, we can I can show you something. So this is how the Kubeflow website looks like. So if you want to have any more questions about Kubeflow, you have to like go to this website. But if you don't want to, like, because this website is very detailed, so you have to hover a lot of places to find your answers, and sometimes you have to go to a lot of hyperlinks, and this becomes very cumbersome. For that, I have made a Medium article. So this is basically, this article has got an end-to-end description how to set up a Kubeflow, a highly scalable Kubeflow cluster which is GPU enabled in Ubuntu 16.04 on top of your existing Kubernetes cluster. It can be a on-premises, it can be a cloud-based. So these have got the end-to-end with the necessary, what is the necessary, what is the use case, industrial use case of Kubeflow, what is the importance of Kubeflow. So right from explaining the importance of Kubeflow to the industrial use case, it has got also the step-by-step command how you can actually install the Kubeflow on your machine. So whenever you want to, if you want to like refer to any manual, so you can refer to this Medium link as a manual for your Kubeflow. So it has got all the commands step by step. It has got all the commands that are necessary for installing the Kubeflow, for deleting the Kubeflow installation, and also installing the Kubeflow pipeline operators and the Kubeflow PyTorch operators. So let us go back and see whether our command is still running. Yes, it is still running. As I told you, it will take some 5 to 7 minutes for the entire Kubeflow setup to come up. Let's see. Let's wait for some time. So this Medium article has been published a long time back already, but only this video was actually pending. So today I found time to have this video shoot. So let's see if it is done. It's still going on. It takes a lot of time, like, because there are almost like 20 25 services that starts up, even more than that. So it takes a lot of time. So as I was telling you, that Kubeflow has got two namespaces. So one is basically the Kubeflow, which has got the core components of Kubeflow, and the other namespace that it creates is the Istio system. Istio system had got the main responsibility of the Istio system is creating a service mesh. So because the different core components of Kubeflow are connected to each other by a service mesh, and Istio is basically responsible for creating that service mesh. So now we can see our Kubeflow cluster has been configured, and let's see if it is properly up or not. And to see whether it's properly up or not, you have to fire this command kubectl get po, and in the namespace you have to set Kubeflow. And you can see the resources. The earlier time when we fired this command, there was no resources. If I have a chance, I'll show you that. See, these are the earlier command. There's no resources found in the Kubeflow namespace. But now when we are firing this command, the Kubeflow components are coming up. So this is how what are the pods there that are under the Kubeflow namespace. And now let us go and have a look. What are the services that are running? So these are the services that are running of the different Kubeflow components. So this is how they look like. And now I'll go and show you how the components under the Istio namespace looks like, the service mesh of Kubeflow. So this is how the Istio namespace service mesh looks like. So now that we are done with installation of the Kubeflow, and we can see that we have currently installed a Kubeflow in less than 10 minutes. Now it's time to go and see the Kubeflow dashboard and how does it even looks like. So in that all our processes and components of the Kubeflow server is up and running with the Istio system, with the Istio system service mesh. Now it's time to go and see the Kubeflow UI, how it looks like. And for seeing the Kubeflow UI, before we actually move to the Kubeflow UI, we have to do something. And let's see. We have to open the services of the Istio system, because as I told you, Istio is a service mesh through which the different components of the Kubeflow connects to each other. They talk to each other. So the Kubeflow UI is basically an integrated system where you can see all the components of Kubeflow. And for seeing this Kubeflow UI, you have to basically go to the Istio ingress gateway, and let's find out how the ingress gateway service looks like. So this is basically the Istio ingress gateway. So you have to forward this, you have to like basically get hold of this ingress gateway channel, and for getting hold of this ingress gateway channel you have to use this command kubectl port forward, which basically it forwards the ingress gateway container port 80 to 15017 port of your local machine. So we'll run this command, and it has forwarded this port, and let's see if it is running. And now we'll go to the local host. We are seeing that we are on the local host port a 15017, and this is the Kubeflow UI page, and you can use this UI to upload a pipeline, or maybe to view your pipelines, and to do several other functions. Distributed deep learning part 2, where we have learned how we can set up a distributed Kubeflow cluster on top of our existing Kubernetes cluster. In the next video, we'll learn how we can train a distributed deep learning pipeline using Kubernetes PyTorch operator, and that too GPU enabled. And we'll also learn how we can deploy Kubeflow pipelines for automation of our Kubeflow jobs. So that's all for today's session. Thank you. Have a nice day. Bye bye.